Good afternoon, everybody. Welcome to Wednesday afternoon at Chem 170 Organic Chemistry with your host, me, Dr. White. Hi, everybody. Hopefully, you're all having a great day. And for those of you turning on your webcam, thank you. For those of you who are here, thank you. I better thank myself. Nah, that gets hokey. All right, it's Awful Humor Wednesday. You and I both have to put up with that. All right, let's go through the game plan. I got a couple announcements. We're going to go through the alkenes and alkynes problem set. Then we'll should finish up the aromatic compounds problem set. When we do, today's Wednesday, Monday, I will go through the aromatic problem set, and then we'll do our lab. And some announcements. First of all, let me remind everybody, tomorrow is the deadline to hand in the lab we did last week. I'd like the fancy hand signals. Yeah, anyways, but labs are easy points. Hand them in. If you don't, you get zero. You get enough zeros, that's going to hurt your grade. And I've seen it happen, both face-to-face and online. So hand in the labs. All you have to do is download the lab from the assignment area D2L and then answer the questions. If you don't have a printer, write it out. You don't have to write the questions out, just your answers. With a cell phone, take pictures, convert that into PDF, single PDF file, and upload it to the assignment area. In lab number 1, I have files, if you don't know how to do it, how to convert pictures from a cell phone. Actually, a cell phone doesn't do that, it does this. But anyways, that you can take pictures. Actually, if you have mine, you go like this. But anyways, how to take those pictures and convert them into PDF file. If you have any problems, come and see me. I'll help. I always will help my students. Anybody else who needs my help, I try and be a helpful person. All right, that's one thing. Next thing, a week from today will be test number 1. And between now and Sunday, I will send out an email, also post an announcement about test number 1. Historically, it's usually 10 pages. I don't know how many problems. Of the areas covered will be alkanes, cycloalkanes. It will be alkenes and alkynes and aromatic compounds. There are 3 types of questions, and I'll have this in the email, but I'll tell you this now on my test. The first one is general knowledge. And what would be a general knowledge question? How many bonds to carbon? Yep, 4. That's general knowledge. And also I asked real world questions like, I don't know, what functional group causes carrots to be orange? Double bond. And things like that. There's only usually a few points on that, less than 10. On this test, because we've spent a lot of time on it, about half the points, 50 points approximately, will be on nomenclature questions. There's 2 types of nomenclature question. First type, give the IUPAC name for the following molecule. The second type is, here's the name of the molecule, IUPAC are common, and we've only done one common name, and that's acetylene, but you should know that, and draw the structure. So nomenclature, 2 types, give the IUPAC name for the following. Second type of question, that is draw the structure from the name. And we've done all that in class. Also, the last type of questions or major area type of question, give the reaction product or products for the following reaction. And we've done those. And finally, under reactions, and I'll only do one on test number 1 because they're a lot harder, give the starting materials needed to make the following product. And I'll have a reaction, just like we've done in class. Now, for my test, and this is true face-to-face, and with you, I'll give you all the time you need, because I'll explain how tests are given, my class. All my tests, if we're face-to-face and I give the students 55 minutes, if you've done the practice problems and studied, you should be done in about 40 minutes. I don't write my tests, so only the smartest person in the class, which usually in math and science was always me, could finish, and most of the other students don't. That's wrong, and I don't do it. The other thing I will tell you, every question on my test, I have gone over the concept of that question at least twice, usually a lot more in our lecture. Also, labs and lectures, anything on the lab will never be on a test. Anything on a test, I'll cover it in a lecture. And I'll explain more next week about our test, but you'll download it. Then the next day, you'll have until next day, 24 hours to upload your answers. By the way, Dr. White is sneaky. And with the pandemic, I learned how to put things in my test to see if anybody's cheating. Please don't. It works. No, unfortunately, it does work. All right, any questions about anything I just talked about? All right, let's do the alkenes problem set. Don't forget, hand in the lab by tomorrow. All right, the way I do this is I'll do a page at a time. I'll do a problem or so on here. And if you want me to do one that I didn't do, ask. Because remember, my class, there's no such thing as a dumb question. All right, as I said, nomenclature questions, give the IUPAC name for the following molecule. And if we look at this, let's do C. What do? Well, you've learned find the longest chain. Now, when I show stereochemistry, the bond angles, CH3, CH2, and then it's bonded to this carbon, then this one, and this one. And that's 5 carbons. It's got a double bond, 2 lines should get your attention like that. And you find the longest chain, name it as an alkane, 5 is pentane, drop the A and E ending, put E-N-E, pentene. So it's E-N-E ending, pentene. Next, for double bond, which carbon of the double bond is closest to the end of the chain? If you start numbering from the left, which I didn't, you'd have carbon as number 3. If you go from the right, hopefully you all know right from left. Later on, I'll teach you the chemical difference between your right and left hand, but that's later on. So carbon number 2 is the closest, so it's 2-pentene. And on each carbon double bond, when you have the same type of atom or group, in my class, hydrogens, you look at them and notice both of these are below the line of the double bond. We call that cis. When they're on opposite sides, we call that trans. Now, if you look at D, double bond, 5 carbons, pentene, 2-pentene, and on carbon 2 is a methyl group. And you probably say, well, how come there's no cis or trans? Well, if you look at this carbon of the double bond on the right, it has 2 CH3 groups. When they're 2 of the same atom or group on the same carbon double bond, you cannot have cis or trans, as you see in A, 2 hydrogens on the carbon of the double bond. That's why there's no cis or trans. Now, when it's in a ring, you name the ring cyclohexane. Double bond. Drop the A and E ending, put in E-N-E, cyclohexene. Because in this class, since I'm not going to mix functional groups till we get later on to fats and oils, when we'll use common names, not IUPAC names. And yes, anything I teach you, I also know the IUPAC name. But anyways, one of the carbons is 1, the other has to be 2. You number it in such a way that the substituents, the alkyl groups, also get the lowest numbers. If this carbon is 1, this is 2, then the methyl group is on 1, the ethyl group is on 3. I have 3-ethyl-1-methyl cyclohexane. Since I am not holding you to the alphabetical rule, don't tell anybody I'm being nice, it'll ruin my image around here. But anyways, if you had put down 1-methyl, 3-ethyl cyclohexane, I would have given you full credit. So one type of nomenclature, give the IUPAC name for the following. Now, if we look at number 2, this is the other type of nomenclature question I put on test. After test 1, you'll know why I call these practice problems. Wink, wink, hint, hint, say no more. That comes from a famous Monty Python skit. I think it's hint, hint, wink, wink, say no more. If you don't know who Monty Python and the Holy Grail, well, that's a great movie. If you don't know Monty Python Flying Circus, go to YouTube. They have a number of skits back. Well, I'm going to date myself. Back when I started working in the late 70s at a chemical company, Channel 11 showed all the Monty Python from England on. It was 11 o'clock at night, always. And all my friends and everybody, we stayed up. All right, let's get back to chemistry. All right, so if we look at B, you start from the right, move left. ENE ending, double bond. That were ANE, butane, 4 carbons. The double bond starts at carbon 2, and it's cis. So 1, you have to show the bond angle, double bond, other methyl of the 4 carbons, and notice 2 hydrogens on the same side. Now, if we look at here, C, we have 5,6-dimethyl trans 3-octane. You start on the right, ENE ending, double bond, that were ANE, that would be octane, 8 carbons. So I have 1, 2, my double bond starts at 3, it's trans. So notice the hydrogens are on opposite side of double bond, 4, 5, 6, 7, 8. And there's 2 methyls, di means 2, methyl, and they're in carbons 5 and 6. Remember, there's 4 bonds to carbon, so you can figure out how many hydrogens go on there. Now, in D, I made a mistake. I'm sorry. That should really be 2-tert-butyl-3-isopropyl cyclopentane, but don't tell the IUPAC police on me, please. But if we start at the right, move left, ENE ending, double bond, cyclopentene. Well, if that were cyclopentane, we have a ring with a double bond. Now, you can start the double bond anywhere. All you're doing is rotating the ring. And carbon 1, one of the carbons double bond is 1, the other is 2. On carbon 2 is a T-butyl group, and carbon 3 is an isopropyl. Don't look. On this carbon right here, I'm missing a hydrogen. Boy, did I mess up here. Well, now you know I don't walk on ice unless it's frozen. Even then, I stay off it. All right. Any questions on nomenclature double bonds? All right, let's look at reactions to double bonds. And here, you look for what's different. What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond should get your attention like this. Did that get your attention? All right, if we look at A, what's different? Double bond. What are we reacting with? Hydrogenic nickel. hydrogen, nickel is a catalyst, and I didn't write it down here, but it could have been nickel, platinum, or palladium. Double bond, you break the pi bond. Remember, double bond has one pi bond, one sigma, and each carbon of the double bond gets a hydrogen. Now, I wrote it this way. Remember, you don't break carbon-carbon single bonds. And if you were in a classroom, you'd be watching me write this on the whiteboard. And one thing I wanted to show you, you break the pi bonds, there are 4 carbons. Here are the 2 carbons that double bond. Each one gets a hydrogen. And there are 4 bonds to carbon. And the reason I'm writing it this way, because on the answer sheet, I brought this hydrogen and this one up here, so it's CH2. It's perfectly correct to write it this way also. Actually, you should do it that way. It's less work for you on a test, and less work is good for you. And if we look at B, we also have a double bond, hydrogen and catalyst, same reaction. And when you lose the double bond on a ring, you don't show hydrogens. So that's what I did. Oh, one of the things on certain foot rings, you'll usually see it on the internet in the line drawing. And on the right, usually I put some of these, I put the line drawing with rings, and a line at the end of the line is a methyl group. You can write it that way, or you can write it this way. All right, let's move on to C and D. Let's do D. Now, D is the chemistry instructor's favorite trick on a test. Shh, don't tell anybody, I'm giving away secrets, but put a big scary molecule, ooh, big scary, and students get all flustered. Oh, it's big and scary, what do I do? No, you look for what's different, what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond. Should get your attention. Oh, it's broken today. I'll have to fix it like that. And double bond, bromine. What's bromine? It's a halogen. Double bond, halogen, that can be, X can be fluorine, chlorine, bromine, or iodine. You break the pi bond, and each carbon of the double bond gets a halogen, in this case, bromine. You break carbon-carbon single bonds? No. So I have 1, 2, 3, 4, 5, 6 across. I have 6 across, and I have these 2 methyl groups. This is important. The 2 carbons of the double bond, these 2 with the dots, which are these 2, are the only 2 carbons that get the bromine. If you put it differently, I mark it wrong. Now, let's move on to E and F. And what do we have? We look at E, we have a double bond, that's what's different, reacting with HBr. Remember, halogens are abbreviated by X. Double bond, HX, you break the pi bond, 1 carbon gets H, 1 gets X, and it follows Markovnikov's rule. I abbreviate and don't write out Markovnikov's full name, but I still say it to honor his great work. And here, Markovnikov's rule is the carbon of the double bond with the most hydrogens gets this hydrogen from HX. The other carbon of the double bond gets the halogen. And this first carbon double bond has 2 hydrogens. The second one has 1. So the hydrogen goes to the first one. The halogen, in this case bromine, goes to the second. Remember, you don't break carbon-carbon single bonds. I started with 3 carbons, better end up with 3 carbons than I do. Now, if we look at F, again, look for what's different. Well, it's a double bond. And it's the same reaction, double bond, HX. In this case, X is iodine, another halogen. But wait, how do I do Markovnikov rule? I don't see hydrogens on the ring. Well, you count bonds. Remember, there are 4 bonds to carbon. The carbon with the methyl group right here. Can everybody see my little crosshair pointer on the screen? Thank you, Mackenzie. Thank you, Luis. And everybody else who can see it too. Thank you. All right. This carbon has 4 bonds to it in a ring. 4 minus 4 is 0. The top carbon of the double bond has 3 bonds to it. Remember, double bond counts as 2 bonds. And that has 3. 4 minus 3, 1 hydrogen. So top 1 hydrogen, bottom 0. Markovnikov rule says the hydrogen goes to the top, the halogen goes here. And that's what I have. Remember, you don't break carbon-carbon single bonds. So I still have my ring. On this carbon, I still have a CH3 methyl group. On this carbon, I still have the isopropyl group. Hopefully you know what I'm talking about. If not, go back and learn the alkyl groups chart or table I have on D2L. You need to. Now, if you put the CH3 where the iodine is and the iodine where the CH3 is, that's fine. That's correct. All right, let's move on to G. Here we have a double bond, H plus and water. Remember, H plus means acid catalyst, and usually it's sulfuric, but I don't teach in this class. It could be benzene sulfonic or methane sulfonic acid, which I have worked with. I actually had to do a quality audit of a company that was making us those products. And I'll tell that story another time. It was in Birmingham, Alabama in the summer, and it was not fun because, well, I'll tell this story another day. All right, double bond, H plus acid and water. Remember, water, H2O, can be thought of as HOH. And here, double bond, you break the pi bond. The hydrogen from water goes to 1 carbon. OH, called the hydroxyl group, goes to the other carbon. And it follows Markovnikov's rule. Carbon with the most hydrogen, double bond gets the H. And this reaction, the other carbon gets the hydroxyl group. Well, this has 2 hydrogens. This has 1. Hydrogen goes there, hydroxyl there. You have 3 carbons. Start with, you end up with it. And if we look at H, we have a ring again. The bottom carbon has 0 hydrogens. Remember, 4 bonds carbon. Count the bonds. Top carbon has 1. Hydrogen goes here, but you don't show it on a ring. The OH hydroxyl group goes to this carbon. You got those switched. That's correct. All right. Any questions on alkene reactions? Yep, I got my speakers on. When I first started in Zoom, I forget to turn my speaker. I have 2, they're about this big, like this. Amplified computer speakers are quite good quality. I've had them for years. They don't even make them like this anymore that good. And I forgot to turn on the power switch on the speakers. And somebody was, I can't hear you. I realized, turn on your speaker, Dr. White. Duh. All right. Let's move on. Next, triple bond. Triple bond is this. Remember, it's 2 pi bonds, 1 sigma bond, and the IUPAC, find the longest chain with both carbons of a double bond, triple bond. I always do that. Triple bond. Drop the A and E ending, name it as an alkane, and add YNE. and a number. Since I've never seen it and never worked with it in the decades I've been doing organic chemistry, you don't have to worry about sister trans, and you don't have to worry about it being in a ring. Can't have sister trans no matter what, but I've never seen it in a ring except one time, I don't know how many decades ago. All right, let's get to work. All right, if we look at B, triple bond, how many carbons in the longest chain with both carbons of the triple bond? 5. Pentane, triple bond, drop the A in the ending, YNE, replace it with pentyne. What carbon of the triple bond is close to the end? And that's this one, which is on carbon 1, or is carbon 1, so it's 1 pentyne. Even when it's on carbon 1, you always have to put a number. Now, if we look at D, how many of you put down T-butyl group? Wrong, caught you. But anyways, longest chain, 1, 2, 3, 4, 5, 6. Hexane, triple bond, hexyne. You count from the side of the chain to give the carbons of the triple bond the lowest numbers, but at the same time giving any substituents the lowest number. Therefore, we start here. This is carbon 3. That's why it's 3-hexyne. And on carbon 2, there are 2 methyls, 2 di-CH3-methyl. And even when they're on the same carbon, when you see di, you need 2 carbons. That's why that's 2,2-dimethyl 3-hexyne. That's one kind of nomenclature you should know for next Wednesday, a week from today. And the other nomenclature for triple bonds is give the IUPAC, or I should say, give the IUPAC name for the following, or draw that. I'm stuck on the last question. Draw the condensed structure for the following IUPAC name of molecules. And acetylene, common name, is the simplest triple bond molecule, alkyne with 2 carbons. If we look at C, we start from the right, move left. YNE ending, heptyne, triple bond. If that were ANE, heptane, 7 carbons. The triple bond is carbon 3. And dimethyl, that means 2 methyls di, are in carbons 2 and 5. All right, let's look at the reactions. And if we look at here, we have, what's different? A triple bond reacting with hydrogen gas. Remember, bracket XS, close bracket, means excess. That means you have all the hydrogen in the world. I'm out for a tea break. All the hydrogen in the world that anything hydrogen can react with will. We have nickel catalyst. Hydrogen, excess nickel catalyst. You break the 2 pi bonds. Each carbon of the triple bond gets not 1, but 2 hydrogens. And 3 carbons, break the 2 pi bonds, and each carbon of the triple bond now has 2 hydrogens more. And B, same thing. I forgot to write platinum catalyst, but there you go. I've got it there. Same reaction. Break the pi bonds. Everything else comes along for the ride. And now if we look at C and D, let's do D. What do we have? What's different? Look for what's not a carbon-carbon single bond or carbon or hydrogen atom, because that's where the action is. That's where all the fun is, and it is. And here we have Cl2 excess. Remember, capital XS means excess. And if we have a triple bond, 2 pi bonds, excess halogen, remember X in this can be chlorine, bromine, fluorine, or iodine. You break each pi bond and each halogen, each carbon gets not 1, because 2 pi bond, 2 halogens. And therefore here you have 3, 6 across, 2 methyls. Here are my 2 carbons of the triple bond, which are these 2 carbons, and each one gets not 1, but 2 chlorines. Any questions on alkyne chemistry or even nomenclature? I'm looking at the chat down here, which I always forget to do. All right. One thing I forgot to mention at the beginning of the lecture today, and that is next Monday, I will do my world famous review for test number 1. And I'll do it in here, and students say it helps, and I'll do it because I want to help students. Let me close this. All right, let's get back to aromatic compounds and their reactions. And on Monday, I talked about halogenation. And halogenation is where you take a benzene ring, remember 3 double bonds that are conjugated, that means alternating double, single, double, single, double, single, that's conjugated, that's benzene, or any aromatic compound, but for this class, I'll keep it to benzene, I'll explain why. Halogen plus you need a catalyst, ferric trihalide. For this reaction, I've only ever seen it for chlorine or bromine. You get, and you replace one of the hydrogens on the benzene ring with a halogen, you get HX, like acid, but that's inorganic. And I'm an organic chemist. I tell you, we're really biased when it comes to inorganic chemistry. Especially Dr. White. Of the 4 branches of chemistry, that's probably my weakest. Can you guess which is my strongest? Anyways, on Monday, I showed you this reaction. And the general reaction is this. And remember, you don't want to break ever those pi bonds of the benzene ring because you lose a lot of stability. And that's that. So for this, I can get this. And X is chlorine. Now, watch closely. A mistake I've seen too many times on test 1. Oops, I can't even do it. So in my brain, they'll write this down and I'll give them 0 points. And they'll say, why don't I get points? I just forgot the bonds in there. I said, well, this is cyclohexane, not a benzene ring. Now, I'm going to tell you a story that's true. I only tell true stories. And it's happened more than once, but this one was pretty bad. Student did all the reactions on test 1 without putting these bonds in that I just did in red. And I gave her 0 points. She lost over 10 points where she should have gotten an A. She didn't. Luckily, that was her drop test, and she still went on and got an A in my class, but learned a lesson. What you write down structure-wise means something. What you don't write down also means something. So it's very important when we're talking about a benzene ring, include the double bonds, or you can do a circle. I think the double bonds are cooler to write out, but that's important. All right, now, On Monday, I had you do this one. And the answer was this. Don't forget the bonds or circle. And you get bromobenzene. Now, listen carefully. This one and this one, those are the only two halogenation questions I can put on test one. What do you mean? You can have stuff on the ring. Yes, but then that involves something different. I'm going to turn the switch, click off. This won't be on a test. If you have something on the ring, and for some reason, organic chemists use the letter Z when we're talking about groups on, and it can be nitro, it can be others that I haven't taught you. This incoming halogen can go here. This is the same on this side. It can go here or here, or it can go here. These are the ortho position. These are the meta. And this is the para. So where does it go? Well, we know now there's a way of determining that. And I could spend about 2 hours teaching you that, and you'd still probably get it wrong. And because I've tried that a long time ago and realized, hold on 1 second. Sorry about that. 2 more rings. I wanted to check it wasn't the governor of Illinois or the president, and it wasn't. I don't even know who I am. All right, stop, answer machine, pick it up. Thank you. I always forget, is it 4 or 5? Now it's done. All right, so we know how to do this, but for this class, because I only have 1 semester, we had a 2-semester organic. I'd be teaching you this reaction when there's Z. I'm not going to teach you this. By the way, Z is called the director. When you have a substituent on an aromatic ring and you're doing a reaction, Z directs the incoming group where to go. And I won't teach that. So this reaction, this is the only one I can teach you. And I have these 2. All right, let's move on. Let's talk about nitration. And nitration is where you put an NO2 group on a benzene ring. Now, remember our nitro group is NO2. Now, this is nitric acid, this is sulfuric acid. What I'm going to write now, switch is going to be off, but it helps you understand why you have the 2. Think of sulfuric acid as H+. I can write nitric acid like this. And the non-bonding electrons on oxygen attracts the proton from the acid to give us this. But now this has a plus charge. Now, does anybody say anything interesting in this intermediate? 2 hydrogens on an oxygen. 2 hydrogens on an oxygen. 2 hydrogens and an oxygen. That's water. And what happens is, and this happens a lot in organic chemistry, minus H2O means you lose water. When you have a leaving group or group of atoms that can leave as a stable molecule. Trust me, water is a stable molecule. It does. And when you're done with that, what you're left with is nitronium cation. And that's looking for electrons in the worst way. And where there are electrons, these double bonds attract it. And that's how the nitro groups are. You also get back, you'll get water. And when this reacts, it also gives H plus from the what comes off from the ring. The hydrogen from the ring leaves as H plus. So truly, this is a catalyst. But what that means is, on a test, the only reaction I can ask you, since I'm not hold on. Now you can put the H2SO4 on top, the HNO3 on the bottom, but this is the only reaction I can ask for test number one, because we're not doing directors having something on the ring. We'll do a lab with that, but that's later on in the semester. Now, one thing I should point out, nitro is NO2. Don't forget to put the double bonds in the ring or the circle. Common mistake on test number one, people see NO3 and don't realize you really are reacting that. And that's wrong, and I give you 0 points because it should be NO2. Now, the next reaction is called sulfonation. And that's where you react sulfur trioxide, SO3, and sulfuric acid, H plus, H2SO4, and you put on a sulfonic acid group. And that's the only reaction I can ask on test number one, because I'm always going to start with benzene. Now, common mistake students make is they write this. And that doesn't exist. So it's wrong. They'll say, well, I just forgot the hydrogen. Well, that's an important thing. So make sure you don't do that. All right, let's move on to the next reaction, because this is the only reaction I can ask you. Benzene, SO3, H2SO4, benzene ring with SO3H. I should point out that this is an important reaction because this reaction helps make a molecule that I'll teach you way later in the semester. That's the key molecule in your laundry detergents. So why are you learning these reactions? Well, this one helps you make laundry detergent. I don't know about you, but I like clean clothes. All right, now the last one I want to talk about is Friedel-Crafts alkylation. For many years, the last 20, 30, I stopped doing it, but for many, many decades, if you discovered, I think they still do it, but not as much as they used to. If you discovered a very important reaction, and I don't like the word even discovered, if you created one, invented it, that sounds better. it was named after you. And two British, I believe they're British chemists, discovered the following reaction or invented, and they were Friedel and Crafts. And that's why it's called Friedel-Crafts Alkylation. And here we take a benzene ring, react it with an alkyl halide, and I'll explain what RX is, with a catalyst, aluminum trihalide. And X is usually chlorine, but it can be bromine. And you replace one of the hydrogens here with this R group. And you also make acid, but that's an organic. But this is a special reaction. Of all the hundreds of general reactions that I know, there are only a handful, like 20 or 25, where you make a carbon-carbon single bond. And this is one of them. Very special, very rare, and very good to be able to do. So let's take a look at this again. And here, you remove one of the hydrogens and make a bond to R. Now, R is the way organic chemists like mathematicians use X, Y, and Z for variables. R means anything with carbons and hydrogens, and usually alkanes. That can be different, but for this one, yes. And on one of the carbons, you have a halogen. If I look at the clock, I think this is about time for us to take a break. So let's do that. Let's take a 5-minute break, come back at 1:55 if your clock is like mine. And I'll see you in 5 minutes. I'm gonna go and get up and stretch. Time to get going. All aboard. All right, welcome back. Let's get back to electrophilic aromatic substitution and the Friedel-Crafts alkylation. Now, why is it called alkylation? Because you're putting an iron alkyl group on a benzene ring. Now, an important thing to remember, the carbon in R with the halogen is the carbon in R here that's bonded to the benzene ring. The carbon in R with the halogen is the carbon that will be bonded to the benzene ring. And the question would be, give the organic product or products for the following 3 points each. And up here, don't forget, we're making HX, but this is inorganic. And if you want to put it down, feel free to if it helps you, but you don't have to. So let's do this one. What do we have that's different? Ooh, benzene ring. What do we have here? Carbon, hydrogen, what's different? Ooh, halogen on a carbon, Rx, and we have a catalyst, aluminum trihalide, in this case, tribromide. Remember, X can be chlorine or bromine. And what happens is you replace one of the hydrogens on a benzene ring with the R group from here. What's R? That's R. So my general reaction tells me I have this. My R group is 3 carbons. Now, this is important. What carbon is the halogen attached to? The end one. And do you break carbon-carbon single bonds? No. So the end one will get bonded to that. And we've now done something very special, very rare, and very good. We've made a carbon-carbon single bond. And we've now made N-propylbenzene. And that's Friedel-Crafts alkylation. We put an alkyl group on a benzene ring. Your turn. Give the organic product or products for the following. 3 points each. Ooh, now we're getting into some good chemistry. And I'm happy. No, I'm not going to sing the Ren and Stimpy song, Happy, Happy, Joy, Joy. Don't want to ruin your day. You people know who Ren and Stimpy is? The cartoon? No, it's one of the grosser ones that used to be on TV. I remember, just put down yes. If you're not done, wait until you're done to answer yes. And it looks like everybody's done. So my turn. And if we look for what's different, oh, I've got a benzene ring. Here, carbon, carbon, what's different, what's not carbon, what's not hydrogen. Ooh, a chlorine attached to carbon. And we show that by Rx. And then I've got a catalyst here, aluminum trihalide. Remember, X can be, in our case, chlorine, which it is, or bromine. And you replace one of the hydrogens. Don't forget to put the bonds to show it's benzene with an R group. What's my R group? This, an isopropyl. Notice the halogen is on the center carbon. So you break carbon-carbon single bonds? No, I have 3 carbons in my R group. I have 3. It's important that the bond from the benzene ring is to the center carbon. If it's not, it's all wrong. And I know there are 4 bonds to carbon, 4, 4, and you made isopropyl benzene. Oh, let's do one more. Now, sometimes if the molecule's large, I'm not going to put it above the arrow. And this is a case where it is larger. But I'll put the catalyst below. And the question is, give the organic product or products or following reaction 3 points each. Your turn. And now we're doing very sophisticated organic chemistry, and it's fun. And for those who finish early, please be patient. Try and give everybody time to finish. And looks like everybody's finished. So I'll do it. What's different? What's not carbon? What's not hydrogen? First of all, that's a benzene ring. That's different. Then if I look at this, what's different? Ooh, a halogen on carbon. We call that Rx. What's my R group? These carbon and hydrogen. And I have a catalyst here, aluminum tribromide. And remember, bromine is a halogen, which if I can get it right. Guess what? I can make the same mistake on a whiteboard, have to erase it. Aluminum trihalide. Remember, X can be chlorine, or as it is in this case, bromine. And you replace one of the hydrogens with an R group. What's my R group? The bond from the benzene ring to the R group is to the carbon with the halogen. So I'm going to have my benzene ring. Don't forget to put the bonds or the circle in there. I'll mark it wrong. And my R group is 4 carbons. The second carbon on the chain from the left is the one that had the halogen, and that's the one the bond will be to. And I've made that new molecule. I've made a carbon-carbon single bond. Very special, very rare, and very good. Oh, let's do one more. And on test one, any of the general reactions I've given you, I'll pick one and make it into a synthesis problem. And here, give the starting material or materials. I'll put the S in bracket. And what I'll do is a public service, when there's more than one, I'll put 2 question marks. And the question is, what 2 things would I react with aluminum trichloride to make that molecule? Your turn. This is the fun part, the best part of organic chemistry. But then I'm a synthetic organic chemist. And for those who finished early, please be patient. Bad thing about Zoom, and not everybody has their webcam on. I can't tell if you're done, so make sure you vote. All right, I think everybody's done. So how do you do a synthesis problem? You look at the product. What's different? Well, I've got a benzene ring. That's different. Well, wait, there's something on a benzene ring. This. Oops, somebody should have caught me. I forgot to put the 3 there. Remember, when I make a mistake, let me know. And that T-butyl group is R. And here I have aluminum trihalide. X can be, in our case, it's chlorine or bromine. And what do you react to make that a benzene ring plus an alkyl halide? Well, one of these question marks is the benzene ring. Don't forget to put the lines or circle in there. My R group here is a T-butyl group. How do I know that? The carbon bonded to this benzene ring is the carbon that has the halogen X. In this case, X is chlorine. I know there are 4 bonds to carbon, so I can put in my hydrogens. And that's how you do it. And let's move on. All right, next couple of slides, click, switches in the off position. That means this won't be on a test, but it's still something I'd like to talk about. It's important. And as of now, before this slide, I have covered all the material that will be on test number 1. One of the things I always try and do, more than that, I really do it, is I always finish up the material in a spring and fall semester 1 full week before I give the test. And that gives you time to practice, so you do good on my test. All right, let's talk about polycyclic aromatic hydrocarbons. Poly means many, cyclic rings. Aromatic, 2n plus 2 pi electrons conjugated in a ring. Hydrocarbons, only carbon hydrogens. And those are aromatic hydrocarbons with more than one ring. Now, one of the things I didn't talk about in cycloalkanes is what we call fused rings. More than one ring that shares carbons with another ring. And here, naphthalene, this molecule, you have 2 rings, let's call this A and B. They share common carbons, each one is a 6-membered ring, and it has 2, 4, 6, 8, 10, 2n plus 2 pi electrons. Remember, each double bond, a pi bond has 2 electrons, and naphthalene is aromatic. And therefore, that's poly, meaning more than one ring, cyclic ring, aromatic hydrocarbons. And I don't know if people use them as much as when I was a kid, but mothballs. Mothballs are essentially naphthalene, which is a white solid at room temperature, pressed into these little balls. And you put them in closets or in drawers where you have wool, and moths don't like the smell of that, so they stay away. And my parents and grandparents use them all the time. They have a very strong characteristic odor. Now, switch is still off. Let's talk about something, and it's called graphite. Graphite is a material that's used in our daily life. Graphite has been used as a lubricant between metals, and also the lead in your lead pencil, like my mechanical one, is not lead, the element, it's lead, which is graphite and clay. Back in 8th grade, I remember, this is a funny story. We had an English class, you were given 3 other your classmates, and the 4 of us had to write a chapter each of a novel we wrote, or a little story. And the guy, one of the people I was with, wrote that someone killed someone else with a pencil. No, it wasn't John Wick, by lead poisoning. And I said, there's no lead in lead pencils. That's not real. And he said, oh, I don't care. The English teacher doesn't know chemistry. And she didn't pick up on that. But anyways, let's talk about graphite. And graphite looks like this. And it has this structure where it has sheets of 6-membered rings fused together. They don't show it in here, but each one is aromatic because they're sharing this like a naphthalene. So think of sheets of paper, and each sheet of paper is a layer of these rings. Now, the strength of each sheet is enormous, but the strength of putting them layered on top is not. You know how you can take a piece of paper and just pull it off a pile of papers, but the paper itself is stronger? Well, the same thing with graphite. Now, about 15 years ago, give or take a year or two, these 2 very creative scientists, for Up to that point, organic chemists or chemists in general said graphite is made up of sheets called graphene, each sheet graphene, but you can't isolate it. Well, they did, and they won the Nobel Prize for that, which they were justified to win. How did they do that? They used what's called an old crystallographer's trick. They took a piece of graphite, that gray stuff, and put some Scotch tape on it and carefully pulled it off. And on the Scotch tape was one sheet of graphene graphene from the graphite. They put that in the solvent to dissolve the tape, and floating around in there were sheets of graphene. And the thing about graphene is it's extremely lightweight and it's almost as strong as steel. And you can use that to make things that are ultra light and very, very strong material-wise. Problem is, how do you make tons of it? And people are trying that and have been working on that. They're getting closer. Think about an airplane or a car that instead of steel for the body, you have this sheets of graphene made up of that body. It'd be ultra light and ultra strong, and you could have really good, remember switches off on this, really good mileage because you've lost most of the weight of the steel. And that's why the United States government and a lot of other countries throughout the world, like China, Japan, Germany, England, are pumping billions of dollars into this research. Now, the original research before graphite was, well, you take graphite, and if you take the sheet and wrap it on itself, you can make a tube, and those are called nanotubes. And before the two chemists figured out with tape that you could isolate graphene from graphite, graphite was used to make what's called nanotubes. And they're the same thing, very strong. This is about 1995 when Smalley of, I think, University of Texas, Dr. Smalley, and a Japanese professor, who I can't remember his name, I should, but I don't right now, independently discovered nanotubes, and they won the Nobel Prize for that. So this is something I just wanted to talk about. And here are the nanotubes. And guess what? We're done with the chapter. Remember the polycyclic, aromatic hydrocarbons, this and this and this, switch was off, won't be on the test. All right, how are we doing from time? We're doing good. We'll have our lab in a little while. And as I said, the first two classes, I stole some time, but generally when we're face-to-face, we do an hour lecture in the lab. Here I can spend the lecture a little longer, and I will. And guess what time it is? It's new chapter time. It's new functional time, group time. It's time for me to open the folder with that lecture. All right, everybody see alcohols, phenols, and thiols on your screen? Uh-oh, I better check. Yeah, you see it. You see chapter 7 on your screen? Thumbs up, people. Give me a thumb. Thank you. Sometimes Zoom tells me you can, you can't. All right, this chapter, I'm going to teach you a lot. Part of it's going to be real. Thank you, Shannon. It's going to be real stinky. I mean, stinky. And other things, well, you better be careful, alcohols. And let's talk about alcohols. What are alcohols? Alcohols have the general formula ROH. OH, notice I got colorful on this slide. OH, hydroxy group, are carbons. So carbon with a OH group is called an alcohol. You've heard the term alcohol for one specific alcohol, but in general, there are many different types of alcohol. And let's talk about a little alcohol. And this will not be on test number 1, but it will be on test number 2. When you have a hydroxyl group on an R group, that's called an alcohol. And here, once again, when you look at an organic chemist, look for what's different, what's not carbon, what's not hydrogen, what's not a carbon-carbon. Double bond should get your attention immediately. So let's look at a molecule. OH counts as one bond. That's why this carbon has one hydrogen, 2 bonds to carbon, 1 to the hydroxyl group OH, 4 minus 3, 1 hydrogen. Now, if we look at this molecule, what's different? Ooh, an oxygen with a hydrogen hydroxyl group on a carbon, that's an alcohol. So look for hydroxyl group on a carbon, that's an alcohol. Now, what we'll be doing next number of chapters is I'll introduce you to a functional group. Everybody say hello to the alcohol. Oh, that was hokey. And then we'll talk about nomenclature. Now, alcohols, the hydroxyl group OH in alcohols is indicated by changing the ANE ending of the longest carbon chain with the hydroxyl group to ANOL. You drop the E, add OL. A number is used to use a number to denote the carbon the hydroxyl group is on. What I don't have here is that carbon has priority, should always get the lowest number. And the rest of the IUPAC rules for alkyl groups are followed. So let's look at this. How many carbons are in the longest chain with the carbon with the hydroxyl group? 1, 2, 3, 4, 5. That's pentane. And for an alcohol, drop the E and replace it with OL plus a number. And what carbon is that on? You numbered from the end of the chain. Remember, always for acyclic compounds, you start at the end, never anywhere in the middle. It's a common mistake on test 1. So this is 1, 2. We start the other way, 1, 2, 3, 4, which is smaller, and hopefully all pick. First of all, it's pentanol, and this is 2-pentanol. Again, find the longest chain with the hydroxyl group OH. Name it as an alkane. Drop the E, add OL plus the number, and remember the carbon with the hydroxyl group OH gets the highest priority, meaning it gets the lowest number. Now, IUPAC has rules when you have other functional groups, which ones have priority over which ones. We will not encounter that in this class. I designed it just to give you the basics. If I had a double bond in there, the alcohol has priority over double bonds. But anyways, you don't have to worry about that. Let's have you try one. And a question is, give the IUPAC name for the following molecule, 3 points each. Remember, alcohols drop the E, from the name of the longest alkane chain with the hydroxy group carbon, add OL, and then a number. And the rest of the alkyl groups, you do the same. And remember, when you're done, don't forget to vote or say yes. Or if you want me to just go ahead and do it, you can also say yes. All right, looks like everybody's done. Question is, give the IUPAC name for the following. 3 points each. Look for what's different, what's not carbon, what's not, an oxygen with a hydrogen and a carbon. That's an alcohol. OH on a carbon, alcohol. How do you do an alcohol? Find the longest chain, name it as an alkane, drop the E at the end, and replace it with OL plus a number. So here we have 1, 2, 3, 4, or 1, 2, 3, 4, 5. Well, longest chain is 5. That's pentane. But for alcohols, drop the E at the end of the alkane name, add OL plus a number. And that gets the highest priority. So add the OL, and this is on carbon 1. That's 1, 2, 3. As soon as I say 1 pentanol, this is all spoken for. Oh, look, we've got something left out. It's your old friend, the methyl group. And what carbon is it on? 3. So that's 3-methyl-1-pentanol. And that's how you do it. If I look at the clock, guess what time it is? It's lab time. I once had a class that every time I would do what time it is, they'd all shut their notebooks and start getting ready to leave. I said, no, I don't let you out early ever unless it's a tornado drill or something like that, or the school closes because of a snowstorm. So it's lab time. Remember, today's lab is due next week. Don't forget, the lab you did last week is due by tomorrow. Hand it in by uploading it to the assignment area of D2L. If you have any questions about anything, including labs, always feel free to come to my office hours. Don't forget, I have an office hour tonight from 6 to 7:15 on Zoom. Stop by and say hello if you need help. All right, everybody see the alkanes, alkenes lab on your screen. Thank you. Now, if we were face-to-face, I'd be doing the same setup or introduction as I'm going to do now. The only difference is I'm going to give you the data, but you still have to use your mind to answer questions. And all hydrocarbons are very flammable. Don't light any matches. We don't even have any in the lab, but I tell people don't. And if we're in the lab, I'd be telling you once we get in there, the proper waste bottles. We don't dump things down the sink. All right, now, the labs, and I think I mentioned this, I wrote these, and part of what I did, and unfortunately this is the part you won't have to do, be able to do, is most people will never handle hydrocarbons again after this class. So what's something important? Well, their odor. So I have people put a little, these are all liquids except one is a solid, on a piece of paper that's cut up. Dr. Daly, who does the lab setups for us, he's the lab manager. He has actually pieces of paper towel cut up 2x2 squares. When we're face to face, the job he's done for me personally has been amazing. But anyways, you smell it and you put down your observation. Now I'll talk later about odors, and each person has, based on their life experience, interprets odors differently. In fact, one of the hardest problems I had to solve dealt with odors, and there was $60 million a year writing, did I get it right or not? I did. I'll tell you that when we get into quaternary ammonium salts. Not a fun time of my life. But anyways, you'd be smelling hexane, octane, octene. Now, depending on which octene Dr. Daly has in stock, and let's do this one octene for today. You would smell that, and then limonene and naphthalene. Now, notice I have here, when you hand this in, you should hand in this chart where you draw the structures underneath for hexane, octane, 1-octene, limonene, naphthalene. For limonene, naphthalene, use Google. When you're searching with Google to find a structure, put in the words chemical structure and then the name of the compound. And it always works for me. And you can use other search engines. I rarely use Bing. What's the new thing that's capped something that's supposed to be AI, artificial intelligence? I haven't done that yet, played with it. All right, so that's the first one. The next one, there are classic reactions that help you identify, do you have a double bond in the molecule? And these go by visual observations. And this was before the modern electronic equipment, modern in the last 50 years or so, been developed, and such as infrared spectroscopy, both hydrogen and carbon nuclear magnetic resonance spectroscopy, which I know. And before that, they used chemical tests that showed a color. And this is one of them. And what I have, and I'm going to write it down in a slightly different way. If you have a double bond in a molecule and you react it with a halogen, remember X here can be fluorine, bromine, chlorine, or iodine, you'll break the pi bond. And I taught this to you. Now, it turns out most organic compounds with a double bond are either clear, almost no color at all, or slightly yellow. I use a scale, but you're not familiar with it. That's called the Gardner scale. Usually they're Gardner 2 or less. And when you react it with bromine, in solution, Br2, this is a reddish brown. Turns out the dibromo compounds are clear also. I should have put or here, or slightly, if I could spell it right. I tell you, I was always the first one down in spelling bee. Slightly yellow. So this is a great test to determine is there a double bond in a molecule, because this happens almost instantaneously. And if you have a double bond and you add bromine to it, and you mix it up, and you wait a minute or so, if it's reddish brown, you didn't have a double bond. If it stays clear or slightly yellow, when you add the bromine solution, guess what? You have a double bond in the molecule. Now, I'm going to ask you to do this on your own. Please watch the YouTube right here, and you can see how quickly, when you're adding bromine to test tubes with the solution with a double bond, changes. Now, bromine is a very dangerous chemical. It will burn your skin. Now, normally, I used to have students where you wore rubber gloves, but I had an accident at the other school, and I know why it happened, but it still boggles my mind, where one student accidentally, and it was an accident, got bromine solution on the back of the neck of another one. Now, I won't go into why that happened, but after that, I said, no, I'm going to do this myself. You all watch. And what you'd watch me doing in small test tubes, put about 5-10 drops of the hydrocarbon to be tested, add a few drops of bromine, mix it. It says wait 5 minutes. No, within a minute it's done. And then observe. Now, if you were watching me do this, I'd have cyclohexane, cyclo-1-hexene, and again, Dr. Daly, let's make that 1-oxene. You have limonene. And cyclohexane, no double bond, so it's red-brown. Double bond, 1-hexene and 1-octane, it stayed clear. So that shows you it's double bond. Now, limonene, which I show, or limonene, which I showed you, has a double bond. Now, to make this exciting, I do two unknowns, cleverly named unknown A and B. And when you add bromine to unknown A, it's clear. When you add bromine to unknown B, it goes to red-brown. And you'll be asked questions about A and B, does or does it not have a double bond? And that's this one. Now, the last one is a reaction I haven't shown you in class, lecture-wise. Remember, anything we do in the lab will never be on my hourly or final exam. And let me write the reaction over here. You have a double bond, and this is potassium permanganate, KMnO4. And in solution, that's purple. You can't miss it. It's purple. And this is called an oxidation. And what it does, and I won't go through the mechanism, it breaks the pi bond, and each carbon gets a hydroxyl group. Now, this is an oxidation reaction, a reduction reaction. This is an oxidation reagent, but in the reaction, it's reduced. And what you get, one of the species is manganese dioxide, MnO2. And the best way to say how this looks is it's got a muddy brown color. If you take dirt and put water on it, you know, you have that characteristic muddy brown or dark color. Well, that's what happens. So if you have a double bond in a molecule and you add the purple manganese dioxide, if you see a muddy brown particulate floating around your test tube or on the walls of the test tube, you know you had a double bond. If it's purple, well, the KMNO4, potassium permanganate, did not react. And that tells you you didn't have a double bond. So if it goes muddy brown with KMNO4, potassium permanganate, you do have a double bond. If it doesn't and stays purple, you guess what? Don't have a double bond. And this one you'd actually do in the lab yourself. And I have a YouTube here for you to watch on your own to see this, and you really should watch those. And if we were in a lab, excuse me, you would take about 10 drops of the dilute solution, put in 5 or 7 drops of the alkane or alkenes to be tested, mix it, and let me show you something. Oh, I got the hiccups. Hold on, anti-hiccup stuff. If this were a test tube, never ever mix a test tube like this ever, because you can get chemicals on yourself or chemicals on other people like the instructor. One way to mix it is hold the test tube firmly, and I mean firmly. Take 2 fingers and go 1, 2, 3, 4, 5. It's mixed. Don't tickle it. You really got to hit it hard. Now, the other thing which we have at ECC, we got a couple of years ago, they're way fun, are these vibro mixers. And you have a rubber disc underneath a motor that you can adjust, and you take the test tube and you push down the rubber disc in the center and hold this firmly, and it goes like this, much faster, like this, and it mixes up real good, and they're fun to play with too and use. But that's how you mix it. And then you'd observe after about 2 or 3 minutes, is it purple or did it go muddy brown? And once again, let's make this, because sometimes he has 2-octane, most time it's 1. I never know till we do the lab and I see what he puts out for me. But anyways, cyclohexane purple, no double bond. Cyclohexane muddy brown. Ooh, there's an EN ending double bond. Oh, it's unknown A and unknown B. And if you took unknown A, reacted with the potassium permanganate, you'd get in the test tube, you'd see a muddy brown. If you took unknown B and reacted with potassium permanganate, it would be purple. Now, I have here questions for you to answer, and please use your experimental results to justify your answers. And these are the questions you need to identify or answer for this lab, which is due a week from tomorrow. Not a week from today. Well, it'd be good to get it in a week from today. And with that, I'm done for today. Hopefully you had a good afternoon with Dr. White. You learned a lot of nice stuff. Remember, a week from today will be test number 1 after class. And I'll explain more on Monday. I'll send out a password that you can open up the PDF file from the assignment area and take it. And you'll have until next day to finish and upload it. So you have plenty of time. And don't forget, on Monday, I will do my world famous review for test number 1. I also tonight will have my office hour. And with that, have a great rest of the weekend. I'll either see you tonight or I'll see you next Monday. And with that, I'll say, gang gesund, goodbye. Stole that from Granny to Beverly Hillbillies.